Hello everybody and welcome back. So in this next lesson we're going to talk about channel references, and although we have spoken about this before and used it in very basic ways, today we're going to be talking about it in all of the complex and kind of really weird and wonderful things that we can do with it to grab just different variables from channels, evaluating them with segment expressions, all the different types that we can cast with. And then also we're going to talk about ramps and how to get those to auto-generate correctly. And then also just a couple of tricks and things that I found in the help file in relation to channels. So let's get started. Right, so I've just got a basic scene with a couple of grids here. We just need some geometry to write some data to. We're just mostly looking at what's coming out in the geometry spreadsheet. So I've got an attribute wrangle, and I'm just literally creating all of the different types of basic channel references that we can, just to show you all the different types that we have. Okay, so if we pop open the help file, I've got the channel float expression open, but you'll see that there are a whole variety of different types: channel string, integer, vector, matrices, two float vectors, everything. Okay, so and in here you're also going to see that there's two different modes. There's one where we just reference the channel, and then another where we reference the channel and then time in seconds. Okay, so it's important to note that this is seconds, not frames. Okay, so we're going to have to convert that, and I'll show you how to do that. So this is a very useful second mode that a lot of people neglect and don't sort of think about. So we can actually just, without having a time shift, if we just want to grab a certain value within a channel on a certain frame, we can do so. Or we can just be looking constantly ahead and behind to somehow interpolate those values. Okay. But yeah, so let me talk about the different types. So obviously float is a very simple one, and it's just CHF. And normally if you just do the CH, so without casting it, just CH will then normally come out just as a float, because that is kind of the default that Houdini expects. Okay, so here we have our my float value. And after creating all of these, I ran this auto-generate button. So all of these parameters over here were just automatically created. The only thing I did afterwards was I went and inserted spacers between each one, just so that we could spread it out a little and see what it creates. So there we are, just a float channel. And you can obviously do everything you normally would with this. You can create keyframes and put animation in there. You can alter this, and you can write expressions. I mean, you could go and change this to a Python expression and actually go and write some Python in there or something like that. So basically, creates a channel, and then we can do anything we want inside of here, and then it's going to reference that static value in here, keeping in mind that when it's running over points, it's still getting one single value from here. So these are like your sort of almost like your detail attributes, where it is one for the entire piece of geometry no matter what you're running over. Okay, then we have channel integers, so that's just going to return an integer which just actually jumps from whole number to whole number. We've got our vectors, which is obviously just three values. Okay, so, and we can control each one separately, or if you wanted to, you could channel reference them if you want them to all be the same. So we've done that before, and normally with these, by default, they're created as floats. Okay, so they're three float channels, right? And to reference those individually, remember that you can use the dot, so dot x, dot y, dot z. If you wanted to read a vector channel, but kind of grab only the one component of it, right? So don't forget that. And then we have our CHU. So this is one of the lesser known ones that, a lot of people forget about, is that when you just have a two float vector, then you just use CHU, okay? And then you're going to get just two values over here. So this would be for like your UVs if you don't have a W attribute as well. Then we have string, which we have used before many times, and you'll use this quite often. Okay, so CHS, right? So we can just type whatever we want in here, and it's literally going to put in that string in there. Okay, and then P is for quaternions. Okay, so you'll do that when you create the actual attribute as well. P at, and then I'd call it my quat. But even the channel reference is CHP for quaternion. Okay, don't know why it's P. If anyone knows, let me know. But yeah, anyway, just note that it's a P, not a Q. So that will be a 4 float vector. Okay, and this is normally used for your rotations. Okay, so then we move on to matrices. So the standard matrix is a matrix 4. Okay, so you can use a CH4 to reference the matrix 4 channel, and you also, when you're casting the attribute, it's 4 at my matrix, or whatever you want to call it. Okay, just note that if you do create a variable that is a matrix, you would say matrix my matrix equals, this would be a 4 float vector as well, just the standard matrix, whereas matrix 3 is a matrix 3 and a matrix 2 is a matrix 2, but there isn't you'll see here there's no matrix 4 because matrix is matrix 4. That's just with the variables, but with the attributes, when you cast them, it's 4, 3, and 2. Okay, so just keep that in mind, and that will create a massive 4x4 matrix for us, so we can put these values to whatever we want. Very rarely are you going to actually, have a channel reference to a matrix 4, because, generally humans are not going to want to manually enter these values, but there may be certain occasions for it, and at least you know how now, right? Then same thing for the matrix 3, it's just 3 and 3, and then we get a 3x3 matrix, okay? So like a rotation matrix, and then a 2, which is a matrix 2, right? So just 2x2, which is basically a 4 float vector as well. Okay, right? So these are the different types, and they will automatically sort of, when you hit these auto generate, it's going to create them in the right way. So you don't have to manually go and create this. It's obviously going to name it according to what you've got here, and give you the right type. You may want to, though, with certain types, actually go in and alter it. So you can click on the cog and say edit parameter interface, and it has created a whole bunch of spare parameters. You'll see here I just dragged a separator in here between each of these to give us a bit more clarity. But you can also come in here and specify things like maybe you want to set a range. You can set the range 0 to 5, so then your slider is actually a little bit more usable. Because maybe you're wanting to slide between 0 and 5. Now you can see that at the top it's 5 instead of being clamped. At 5, if you really wanted to be having numbers like this, then this is not useful because it's just always going to be right at the maximum. Okay, so try to get your range right if you're going to be using that quite often. And you can also clamp your range. So then when you try to I'll have to hit apply. Then as you try to raise the value above 5, it's clamped. Okay, so you can set your range. You can change the size over here if you wanted to. So now you could go and set that to a 3 float. Okay, and set callbacks. You can set the defaults as well in here, and channel link it. So there's a lot that you can do. You can also disable and hide if you want, or add a little help tag, or make it invisible if you need, or join it with the next parameter. So lots of cool things you can do with it. You can also change the type, so it'll keep the name, but you can change the type, which in some cases you may want to. For example, your strings, you might find that, okay, just a standard string, sure, you want to reference it, channel reference it as a string, but what you actually may want is a menu, like an ordered menu or something like that, which technically the type is still string, but you want access to this menu here, so that you can have something like, foo, which would be, and then, oh, sorry, sometimes it does this where it doesn't accept the first token. You have to go and reinsert it, so just careful of that. And then let's say, well, I don't know, just entering random things. So when we have this type, if I apply, you'll see here that it is one of these menus, but what it's reading is a string, and the label on this side is what will appear in the menu, but the actual value that comes out is the string. So let me just call it search for string in our, okay, hang on, let me just find that. Sorry guys, let me just try and find our string attribute so we can see the value. There we go, my string. It's all these matrices where there's too many values. So yeah, there we go. So you see it's returning foo even though we've selected something. If we switch to label, it's going to change to whatever. So that's the difference here between our token and our label. Okay, so you may want to use that, or there's a whole bunch of types that you may want to change it to, and I don't think there is a way to get this auto generate to generate something like an ordered menu for you. You have to go in and manually set it. I'll show you just now how to get the channel ramps to cast automatically, and chances are you'd probably be able to do that with your like your float vectors. If you wanted them to be integer vectors, then you could probably just typecast them when you create them, and then I'm pretty sure it'll create them as integers. We'll test it out just now. In fact, let's test that, shall we? Let's just say v at test equals, and then let's typecast a channel vec to vec int. Okay. Interesting. Okay, well, I guess that doesn't work. So yeah, we can't create that. Although here, let's see. Yeah, see. So it's just created a float vector. So we won't be able to cast it like that. Unfortunately, if you do want an integer vector, then you'll have to create a vector, go to the vector here, and then change it from a float to an integer vector 3. So it'll still reference the same channels like here, but you'll see that they will be integers, and you will not be able to insert a half value or something like that. Okay, so that's unfortunate that you can't cast it like that, because the method that you saw now, I'll show you just now on the ramps, is how you actually cast the ramps. So it's very strange that that doesn't work. Okay, so let's move on from the different types. So we're going to talk about segment expressions. So this is something kind of interesting. I'm not really sure how often you'll use this, but if you find a case like this is fantastic and really powerful. So I've created a parameter called test, okay? And I just created some animation in it. I just created 2 keyframes, and then I've set it to linear. I mean, but you can set it to whatever you want. We could Bezier or something like that, okay? And what you can do is actually reference the, so here I'm just straight up referencing this parameter, okay? And I'm writing it into a channel called foo standard. So now we're going to see that this is the standard way of referencing the value in this channel. And as I change the frames, obviously this value is different, so then this will change, okay? But what we're doing is we're reading an interpolated value between 2 keyframes, okay? So along this segment, we know what the previous value is, we know what the current value is, and then this location of here is based on this expression, the segment expression, as well as then obviously the values of the slope and acceleration on both of these keyframes. So what we can do is actually read that channel with a ch and then expr, so expression, right? And we reference the same channel, so test. And then in here, there's a second argument where we feed it a new expression, like a segment expression. Okay, so currently the segment expression is Bezier, right? But if we wanted to read this and interpolate it as though it was linear rather than Bezier without changing the actual parameter itself, okay, then we can do that. So in here, in this expression, if I type linear, now before I hit enter, you'll see that my foo expression and my foo standard are the same. Okay, with nothing inserted there, it was reading them exactly the same. But now, if I hit insert and show you the result, you'll see that the foo expression is reading 5.49353. Okay, so this is a different value, right? Because it's assessing these two keyframes that we had as though it was linear, right? And to show you that, if I take this and change it to linear, right, then you'll see that these two values match because it is now actually assessing this channel as linear, and then this is returning exactly that same. But now we could change this to Bezier, and now it will be reading that other value as though it was Bezier. Or we could change it to constant. Okay, so constant would be that it takes the first frame and holds it and holds it and holds it until the next keyframe. So you'll see here that our expression one will stay static at 3.95 until we cross over the threshold of the next keyframe, and then it will change, right? So without having to have the same channel, and maybe if you want to read it in multiple different ways, then reference it, but then convert it, or somehow have the same keyframes, it becomes really messy. Whereas we can just reference the constant. I think this will actually be used quite often, is because sometimes you want to know what the previous keyframe value was before, so you want to read it in constant, but at the same time you want access to the values in between, the interpolation values. Okay, right? Because you could actually even subtract these interpolation values from the previous keyframe to figure out how much it is interpolating, and you turn that into a gradient to figure out basically between one keyframe and another how the curve and how things are changing. There's loads you could do with this. This is really, really powerful. So this is pretty cool, and I'm going to show you now one other thing that we're going to do with these same two expressions. So I'm just going to disable these two and re-enable these, which are writing to the same thing, but we're just doing two different versions of the expressions. So the CHF one, the channel float reference, is the same expression. It's just that we're using the optional second argument, the second mode, to feed it a time where it should read from instead of our current time. And with the channel expression function, right, you'll see that there is a different function. So you can't just insert the third argument optionally. You have to actually run a CHEXPRF, which is for frame, or there is a T version which will be for time, which is exactly the same as this here now. Remember that our channel float can only reference time. It cannot, which is a bit strange, but it cannot reference frame. There is no version of it that references frame number. Okay, whereas here CHEXPRF lets us just do the short way and reference frame number, which I think is a lot more useful. Very rarely do we reference time. We normally reference frame number. If we have time, we will convert it to frame number. So anyway, so what we're going to do is reference a particular time. So I've created a channel, which is our sample. So in other words, our sample time, which part of this curve should I actually be referencing from? Okay, and as I change the sample, our values here change. And in here, let me just show you the conversion, which is going to bring up another topic that I want to talk about, which is that, okay, so to convert from frames to time, in order to give this expression what it needs, we have to take our sample, which is in frames, subtract 1 from it, and then take that whole thing and divide by the FPS, right? Now let me show you in the help file. This this took me an hour to find this morning because I knew that this page existed and I couldn't remember where it was. And when you search for global variables, local variable, it just nothing comes up. So this, I love the Houdini help file in certain ways. It can be very, very useful. It gives you a lot of valuable information. But man, this page, the search. Anyway, so guys, please write this down. It is on the parameter expressions page for some reason. But anyway, what I'm talking about is when we scroll right down to here, the HScript global variables, okay, which are not only HScript, it shows us the Vex versions as well. So this is why I'm saying this is so frustrating that this is hidden on this page, okay? So yeah, write it down, or use this video as a reference. Like, just honestly, I've searched for this for like, I think it was more than an hour. So anyway, I've done the work for you. Here it is. And it's very, very unfortunate if you look through this list, how few of these, I mean basically 2, have a Vex at version. Okay, I'm really hoping that they are going to be adding more of these, but unfortunately right now we know our at frame and we know at time, which is great. Okay, but look at all the others. There's nothing else, right? So $FPS or $RF start, RF end, which this I was looking for the other day. I could swear there must have been a Vex expression for it. Apparently not. Anyway, unfortunately, when you want to reference these, something like $FPS, you're going to have to do a channel reference so that you have a parameter where you can then insert the actual Houdini, the HScript variable. This is the only way that I have found. If someone out there knows a better method and you're listening to this, please show us the method, because I swear there should be a better way. I know, like in Python, you can run an HScript expression using another expression. So you can tell it, okay, run an HScript expression, and then you just feed it the variable, or and vice versa. HScript can run Python. But Vex, for some reason, seems to be out of the loop with that, and there doesn't seem to be an expression that can run a Houdini local variable. Very frustrating, but this is the only way currently that I know how to do it, is just referencing your $FPS in a channel. Okay, so that's why I've done that over here. So now we can reference our FPS, and just taking our sample -1 just to get it to time. Okay, and then the same rules apply. So now we're just reading from a certain time, so it doesn't matter what our current time is. Even though this test value is changing, our result here is not, because it's reading from a very specific static time. Okay, and then same thing is applying here. We're changing the segment expression that we're reading, so that's why these 2 values are different. Also, I should show you in the help file. So here is that chexpr vex function. It's not a very helpful part of the help card. It doesn't have examples or anything. But that's why I thought I'll explain what it does, because it doesn't really explain. I mean, if you don't know what a segment expression is, then it's kind of frustrating. And you'll see here there's the channel expression frame version and the time version. So these 3. Now, if you go to the graph view page, okay, so under the animation editor, there's a graph view page, okay, then you'll see over here there's a section where it talks about your actual segment function, and that's these. So it does explain it over here, but it's not very explicit. Okay, so anyway, so let's move on. Right. So our last example over here is I'm just on our grid, I'm creating a gradient that goes from the -5, because I know the size of my grid is 10 by 10 and it's sitting at the origin, so I know I'm into the -5 to +5 of the X and Z. So I'm just fitting my x value between -5 and 5 to a value of 0 to 1 to create a gradient. Okay, and I can visualize this gradient by clicking on here. So you'll see it goes 0 to 1. Okay, and then in here I'm going to be referencing using ramps. In fact, I think it'll be better if you see this typed out. So let's start blank. Okay, so we've got our gradient, but now what do we do with it, right? So I'm going to be offsetting the y, so just the p.y value, and I'm adding to it based on a ramp. Okay, so the ramp is very similar to a channel reference. You still, reference an actual channel, and you can still auto-generate them, but it's ch ramp. Okay, so and then we feed it the name of the ramp that we want. I'm just going to call it ramp, but I would suggest you guys come up with more explicit versions, like, otherwise if you've got a lot of channel references and ramps and things, and later you get confused about which ramp is referencing where, especially if you end up with like 20, 50, 100 lines of VEX code, then yeah. So ramp. But then you have to feed it a second argument, which is the driver attribute. In other words, where within that ramp do you want to sample for this particular point? So as we loop over this point, it's going to reference the ramp, which is a static value. But then within that ramp, it needs to read from somewhere along the ramp. And we need to feed it a float value that goes between 0 and 1, because all ramps go from 0 to 1. Okay. So let me show you here. In this case, we're gonna use f at grad, which is our gradient that we created. Okay. And now, if I click here, it's going to auto-generate a float ramp, which is exactly what we wanted. Okay. So I'm sure you guys have used these before. You can expand it here, or you can hide the bottom section as well. You can add points along here. You can even change, you can select multiple points and drag them and change their type as well, change the positions, and okay, right, so you know how to use a ramp. And this goes from 0 to a 1, which means that the value that comes in, we really need to try to make sure that we fit it and that it is a 0 to 1 value. Sometimes you need to normalize or clamp. If you just feed a value that goes 0 to, let's say, 10 into this ramp, then all values that are above 1 are going to receive whatever the value of this last point is in your ramp. Okay, so I guess that may be okay in certain scenarios. That may be what you want, but generally the practice would be to fit or clamp or something. Okay, so this channel reference is very simple, but what if we want to do something like setting color? Okay, and to reference a color ramp, you'll see that it's actually, okay, before I type this, if I go into here and click on this ramp, you'll see that there's two types, a float and a color ramp. So there aren't two different ones. I mean, okay, yes, in this list there are two, a color and a float, but really when you drop them down, it's the same thing. It's just two different modes of the same parameter. So they're both just ramps, right? So if we go and type v at cd equals, and then channel ramp col or something like that, and then we feed it our gradient as well. Okay. Now when I run this, it's going to create another float ramp, and I'm going to have to go and change this, right, to color. And that can become a pain, especially when you're trying to do things quickly and you're also, referencing loads of different channel like colors and stuff. So if you typecast this, now you'll notice that we already had our whole expression was typecast, the value that it's writing into is a vector, but it doesn't read that correctly. Okay. It's not like overdriven parameters where it actually looks for the type that it's being cast into and therefore selects the value or the mode according to what it's being written into. It does not do that. So you have to manually typecast it as a vector. But if you do, then when you auto-generate, we're going to get a color ramp. Okay, so it's not, you know, the most complex thing ever, but it can save you some time. And honestly, it is better practice to have typecast a ramp anyway. So, you know, this is good practice. You might as well write it, and then it saves you a few moments where you have to go and convert it to color. Okay, and now we can just insert, you know, whatever colors along this, and you can see the result. Okay, guys. So that about does it for channel references. Remember, you can... one more thing I guess I should mention is that these channel ramps also have the optional frame. Here we are. The optional time value, the same as the channel floats do, and channel int and string and whatever. They all have that optional additional value where you can tell it which time to read it from. And just remember how to convert. It's the frame number -1. Don't forget the -1. So all within brackets divided by FPS. If you don't put it in brackets, then it's going to do 1 divided by your FPS, and then it's going to subtract that from your sample. Not the right result. Okay, so be careful how you structure this and do it correctly, and then you'll get the right result. Okay, so I hope that helps, guys. Channel references, very powerful. You can use them all the time, so it's good to understand what you're doing. And yeah, I look forward to seeing you guys in the next lesson.